Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is lecture number 18 for that. Okay, in this lecture I will explain you various types of electronic excitation. But before that I think I should explain you a little bit about molecular orbital theory. So according to MO theory, when two atomic orbitals combine with each other, they will lose their original identity and they will produce some different kind of orbitals known as molecular orbitals. Okay, so first of all, let us check two different types of bonding. You know, in organic chemistry, we deal with organic compounds in which main element is carbon and that is non-metal. Which combine, and carbon combines with hydrogen, oxygen, nitrogen, etc. and they are all non-metals. So when non-metal combine with each other, they form covalent bonds. So mainly organic chemistry is related to covalent bond chemistry. So organic is also known as covalent chemistry. So here we have to discuss mainly covalent bonds. There are two types of covalent bonds, sigma and pi. Now how this sigma and pi bond forms according to molecular orbital theory, let us see this one. So first of all, we will draw orbitals. As it is dumbbell, so we expect that this will be p orbital because carbon carry p orbitals and s orbital. So let us call it px orbital. That means this axis become x-axis. And if bond forms on this axis, we call it bond axis also. Okay. Here we will put positive sign and negative sign. It doesn't mean charges, but it indicates directions. When these two atomic orbitals of same means px combined with px having the same symmetry like plus and minus over here, these two will be added with each other and that is known as additive combination. Here, suppose from this center, if we go to left side, we get positive sign. If we go to right side, we get the positive sign. That means at the same distance, we have the same positive signs. That means this must be having I. That is center of symmetry. That means here I is present. If I is present, these two atomic orbitals merge and produce a new orbital like this. In which positive lobe will be large and negative lobes are very small. That means probability of finding electron between nuclei is maximum. It is called positive combination and this orbital is known as sigma BMO orbital. Because I is present in these two atomic orbitals, this orbital is also known as Girard with reference to term symbol. Girard means similar, equivalent. Okay, and it has a lower energy because of attraction. So it has lower energy than atomic orbitals. So this type of orbital is known as molecular orbital, and it is forming sigma bond. So we call it sigma molecular orbital. Now, second type of combination, this is also px orbital, plus sign and minus sign. But these two may have electron with similar spin. That means they do not attract each other, they repel each other. So for that we will put negative sign over here. So negative sign on this side and positive sign on this side means they do not like each other and they repel each other. This is also px orbital. But as you see from center, if you go to left side, you will find a positive sign over here. But on the right hand side, it is not positive but negative sign. That means I is not present. Okay. So here I will be absent. There is no I. So I will be absent. Means center of symmetry is absent. And it is known as subtractive combination. They are combining but they do not like each other. So this is called subtractive combination. We use some mathematical terms over here, and as they do not like each other, this type of orbital will never form a bond. Why? Because there will be no overlapping between these two orbitals, and here you can see there is no overlapping. Here the positive lobe is very small. In front of it there is negative lobe. That means they do not have symmetry. Okay, and this type of orbital with reference to term symbol is known as Ungirad orbital. Okay, so this is called Ungirad orbital, and the name of this molecular orbital, which is not forming a bond but it is of a family of sigma, so we call it sigma star, and it is called anti-bonding molecular orbital, which is having very high amount of energy. This is because of repulsion, so it has higher amount of energy. So it is said that when two atomic orbitals combine with each other, they will form one BMO orbital and one ABMO orbital, and this is the way they form this BMO and ABMO orbitals. Okay. Now, second type of bond is called pi bond. Now see how pi bond is forming. Here we take two atomic orbitals, maybe py or pz with reference to bond axis. This is called bond axis. And this orbital is perpendicular to bond axis. So it can be either py or pz orbital. Positive sign, negative sign indicate direction. And here this will combine with another py orbital which is perpendicular to bond axis. That means these two atomic orbitals are parallel. And here we will put positive sign, negative sign, and they will combine with each other. Now here with reference to this center, if you go in one direction like this, and here you will go here, that means these two have different signs. These two have different signs. One side is positive, another side is negative. That means these two do not have symmetry or center of symmetry. So here center of symmetry is absent. So I is absent. But positive combined with positive, negative combined with negative. So this is called additive combination. And here because of attraction, these two atomic orbitals will come close to each other and they will form two electron clouds above and below bond axis. because of merging of positive lobes and negative lobes. So here positive sign, negative sign. This molecular orbital is different than these two atomic orbitals, and therefore we call it BMO orbital, but it is forming a pi bond, so we call it pi BMO orbital, which is having two different clouds, electron clouds, and it is due to attraction. So energy of this orbital will be very low, and as there is no center of symmetry present in this case, so this type of orbital is Ungirad orbital. That means opposite. Ungirad means opposite or not similar. Okay. Second type of orbital forming by overlapping of this type of orbitals like py orbital merge with py orbital of same kind, but both py orbitals may have electron with similar spin. So they don't like each other, they repel each other. So if you put positive negative sign here, then here we'll have to put negative positive sign. And here these two will subtract each other. So we'll put negative sign between these two. Okay. And sorry, I will use another color so that you can understand that this is negative sign. Okay, so this is, oh sorry, again similar color appear over here. So let me select the new one. This is negative sign. Now if you go from negative sign towards one side, and opposite side, here you will see that positive lobe here, and at the same distance positive lobe is on the opposite side. That means center of symmetry is present, and if center of symmetry is present, we call it I is present. Okay, so here I will be present, center of symmetry is present, so they will form Girard type of orbital. But here these two atomic orbitals do not like each other because they may have similar spin, so they combine but with repulsion. So there will be repulsion between these two orbitals, and therefore this type of combination is called subtractive combination with reference to wave mechanics. Okay, so with reference to wave mechanics, it is subtractive combination. Here I is present. So here when these two atomic orbitals approach each other, they do not like each other, and therefore they will try to move themselves in a different directions from each other. That shows that they do not like each other, and therefore this type of molecular orbital form in which signs are opposite. Okay, but here, as I is present, this orbital is known as Girard. Okay, and as it forms ABMO, so we call it pi star of pi orbital, and so it is pi star anti-bonding molecular orbital. Okay, so this way this type of molecular orbitals are formed. Now I will show you when you want to show both orbitals simultaneously. For example, if you want to show two sigma orbitals, BMO and ABMO, we show it like this, that this is BMO orbital, and at the same level you will find ABMO orbital also. Okay, so here we can show BMO and ABMO orbital of sigma type at the same time. Okay, and this is sigma BMO in the center, and now on the left and right you will find sigma star orbitals. These are ABMO of sigma type. If you want to show pi orbitals at the same time, this is sigma orbital and pi orbitals would be like this. This is pi BMO and these two are pi star ABMO. Okay, so here pi BMO and pi star ABMO. So this way we can show pi star and sigma star orbitals simultaneously. Thank you so much.